Welcome to solverfy.
Here the question is, which of the following molecules exhibits optical isomerism? These molecules are given and we have to decide that whether they can have optical isomerism or not. Now, first of all, we are supposed to know the geometry of the molecule, and by looking at the geometry only, we can say that the molecule is symmetric or asymmetric. If the molecule is symmetric, then it will not exhibit any optical isomerism, but if it is asymmetric, then only we can expect optical isomerism in it. So first one is A, that is cisplatinum, cisplatin complex is given. So platinum is at the center, and this is coordination number 4, square planar geometry. So we can write at the center platinum and 1 bond, 2 bond, 3 and 4. So this is square planar. That means you have to imagine that all the 4 ligand molecules and the central metal atom all are in the same plane. So in case of cisplatin, that means identical should be adjacent. Chlorine, and here it should be ammonia. So this should be the structure of cisplatin, and it should not have any charge when platinum is at +2 oxidation state. So this is A compound. Now look at the molecule and decide whether it can exhibit optical isomerism or not. Now here you can see that this molecule is symmetric. It has plane of symmetry, and by that we can divide it into 2 equal halves. So this cisplatin cannot show any optical isomerism, and its mirror image will be superimposable mirror image, and that is why also we can say certainly that it will not have any optical isomerism. Now come to B. B molecule is trans nickel En2 Br2 when En is ethylene diamine. So it is trans, an octahedral complex with En and Br. So we can make the structure of this also. Nickel is at the center, that means an I is at the center, and this square planar part, and 1 bond is above the plane and other should be below the plane. So here also we can see that these are in the same plane. And if it is trans, Br should be farthest from each other. So above and below the plane, and this position En ethylene diamine is bidentate ligand, so they can form bond here. So this should be the complex given. And here also there is no charge over it. Trans-nickel En ethylene diamine. No charge over it, and when no charge, that means nickel is at +2 oxidation state. So this is the geometry given. Now what happens that we have to decide the symmetry of the molecule. Here again we can say that it has plane of symmetry, this one, and it has plane of symmetry here also, and actually the plane of the board also is plane of symmetry. So by that it can be divided into two equal halves. So we can say this is again symmetric molecule. Symmetric molecule, so no question of optical isomers in this case too. Now come to the next one, C. C is here the C molecule should be nickel at the center. Nickel is at the center and octahedral complex is given. And 2Br, that means cis isomer is given. One bond should be above the plane and one should be below the plane, and this is the octahedral complex. These four bonds and the central metal atom should be in the same plane. This we have to imagine, and Br and Br should be adjacent to each other. So we can see it is this position, and then En, two En molecules. So in between these two, En is present, and in between these two, En is present. So we have to imagine that these four bonds which are making the square planar geometry, and one is above the plane and other one is below the plane. So what will be the position of this En and this En? So by this it is quite clear that this is asymmetric molecule. So this is asymmetric molecule, we have to write here. Asymmetric, that means no element of symmetry is present in the molecule. This whole thing should be inside the bracket. So by this, if it is asymmetric molecule, then it can exhibit optical isomerism, and it will be, we can say, optically active. When a molecule is optically active, it can rotate the plane of polarized light. So we can make the mirror image of this molecule also here, and in the mirror image we can see what will be the geometry. So here at the center we have the nickel, then 1 bond, 2, 3, 4, all are in the same plane. One is above the plane, other one is below the plane, and these 4 bonds are making the square planar part of the molecule. Overall it is octahedral, and Now the question is about the mirror image. So just you have to see the molecule original and put the make the mirror image accordingly. So here with this BR we have this EN here, and EN should be attached to this one, and one EN must be here, and it should be like this. So this whole molecule is the mirror image of the first one, and these are also known as enantiomers. They can rotate the plane of polarized light, and these enantiomers is one is D form and other one is L form. That means if one can rotate the plane of polarized light in the right hand direction, other will rotate the plane of polarized light to the same extent in left hand direction, and their mirror images are always non-superimposable mirror images. So this C molecule is optically active. Active. Now come to D molecule. D molecule is given here. It is the cobalt complex which is tetrahedral. So tetrahedral geometry, central atom, and these two bonds should be in the same plane. Fluorine we can say here and chlorine here, and one bond should be above the plane. Suppose this one, it is Br, and one should be below the plane, and suppose it is I. Now in case of tetrahedral geometry, when all the four bonds are different, then what happens? It is asymmetric molecule. It is again asymmetric molecule, and inside the bracket it should be 2 negative outside it, and it if it is asymmetric molecule, that means it should be optically active. So let us make the mirror image of it. So suppose here mirror is kept, so the other isomer should be cobalt at the center, and one bond is here, and one should be here, and one is above the plane, and other should be below the plane. So here it should be I, here it should be Br, and here chlorine, and here F. So this is the geometry, and this is the enantiomer. They are mirror images of each other. They can rotate the plane of polarized light, but in opposite direction, and their mirror images are non-superimposable mirror images, and that is why uh, they are optically active. Active. And these isomers are also known as enantiomers. If one is D, other should be L. If one can rotate the plane of polarized light in one direction, other should rotate it in opposite direction, and that is why they are known as enantiomers.